Hey folks, in this video I'm just continuing my module on quadratic functions, in general polynomial functions, but specifically quadratic functions. And in this one we're going to focus on just sketching parabolas, okay? But in order to do so, we kind of want to take a different frame of mind. So let's go ahead and take a look up here. I say sketching parabolas in standard form. When we sketch parabolas, it is entirely possible to do so using the equation f of x equals ax squared plus bx plus c in general. Okay, this is not a bad thing, or we could say y equals ax squared plus bx plus c. However, it is really convenient to sketch it in what we call standard form. And the reason why is because when you look at an equation in standard form, it tells you where the vertex is, and it tells you exactly how to open from the vertex, up or down, whatnot. So let's go ahead and start by defining what we mean by standard form, and what we mean by it is this. We say instead of ax squared plus bx plus c, we could learn a way to rewrite this such that it looks like this. We say a times the quantity x minus h, okay, that quantity squared plus k. But the properties of a graph that has its equation in standard form like this are listed here on the right, but we say these properties are thus. We say the vertex is always at hk. And one thing I want you to notice here real quick is this. H has a negative sign in front of it, so it is a liar, that is. It'll say -3, but you can't trust it. It actually means 3. And since k has a positive in front of it, it is honest. It's going to be telling the truth to us. And anybody that's studied function transformations, of course, know that h and k are just horizontal and vertical translation. But also we want to note this. If a is greater than 0, that is if a is positive, then we say the parabola opens upward and has a minimum point. Recall that if a parabola opens upward, it'll go up forever and ever and therefore has no maximum, but certainly has a minimum. And conversely, if a is negative, then we say the parabola opens downward, has a maximum point. Okay. Let's go ahead and just look at a couple of examples. We'll be done with this video, but we say, I say, sketch the following parabolas. And in order to do so, first we want to identify the vertex, and then we're going to identify the a value. And lastly, after we sketch it, we're going to tell whether the parabola has a minimum or a maximum value. So let's go ahead and take a look at this first example here. I'll kind of write it off to the side. We say f of x equals negative x squared plus 1. Now, one thing I want to note here is this. It's not a necessity, but we could have rewritten this as instead, negative 1 times the quantity x minus 0 squared plus 1, and meant the same thing. What this really means is we can already go ahead and identify the a value here. We have the h value is 0 in this instance, and we say the k value is 1. But the important thing to note is if we're going to sketch this, then we already know that the vertex must lie at the point, and I like to put a v in front of it just for emphasis, but we say h is 0, k is positive 1. Recall that the vertex is at hk if the equation is written in standard form to begin with, and it was. So we say we know where the vertex lies, and as a matter of fact, we wanted to identify the a value as well. So we say a in this instance is negative 1, and I'm going to rewrite this as a also as negative 1 over 1. And so sketching this, okay, let's go ahead and take a look at the sketch. We'll just go ahead and throw in some axes here. It's not going to take much. Anybody also, again, who's studied function transformations knows that this is just a downward-facing parabola. It's been shifted up 1. But let's talk about this with the lens of looking at through standard form, which says the vertex is at 0, 1. So we go ahead and sketch in the point 0, 1, which would be, right here because I say so. And I know this parabola opens downward, so I'm going to label this. I'll label it up here on top. We say vertex is at 0, 1. And then that a value, recall that I put it over 1 here because what it's going to do is it's going to tell me how to get to another point on my parabola. It says that my parabola falls 1 every time it runs 1 to the right here off of the vertex here. So not every time, but as we move 1 to the right from the vertex, my parabola falls 1. So we'd go down 1, right 1, and I know this point must lie on my parabola. Not only that, I also know then therefore if that's the vertex, the axis of symmetry is at x equals 0, and I bring this up because if it goes down 1, right 1, then it also must go down 1, left 1, as parabolas are symmetrical. So we say this is my parabola, and it has a maximum at its vertex, maximum value of 1. Okay, so real quick, let's go ahead and take a look at the second example. We say g of x is defined as the function x minus 3 quantity squared or quant squared minus 5. We can identify that our a value in this instance, it looks like our a value here is 1 or 1 over 1 if you will. And then we say the vertex And recall I said beginning of this video, we say the vertex is kind of lying to us. So we say this h value here says -3, or at least it looks that way to our eyes. It's actually a +3. And the k value here is honest, so it's actually at -5. So sketching this, again, we'll go ahead and start by just dropping in the vertex. We'll go right 3, 1, 2, 3, down 5, 2, 3, 4, 5. And from here we had an a value of, 1 or 1 over 1. So, again, we have this vertical axis of symmetry that has to run through the vertex at x equals 3. We'll go up 1, right 1 from here. But since it's symmetrical, of course, all parabolas are about their axis of symmetry. It'll go up 1, left 1. That's why we say here is our parabola. Enjoy.